Hi guys, I'm Paul, and today I'm announcing a new video series titled C++ Implementations. In each episode, I'm going to cover and implement a single C++ feature, either from the STL or something STL adjacent. Now, why am I doing this? First of all, I would like to rehearse and organize my knowledge. Second of all, I know that questions about implementations of certain features tend to appear during the interviews at the top companies. Third of all, I would like to grow this YouTube channel. Now, why do you guys care? Well, this series will be an opportunity for you to familiarize yourself with inner workings of crucial and core C++ features, such as smart pointers, data structures, and maybe some idioms. Now, I will not be covering trivial concepts such as what is a pointer or how does the dynamic allocation work. Well, maybe they are not so trivial, but they are just the fundamentals that explaining them would take a considerable amount of time, and that's not the point of this series. Okay, so let's start with unique pointer. What is a unique pointer? Unique pointer is an object in C++ that models a unique ownership over other object via the pointer to it. Pretty simple. Now, what does it mean? First of all, it means that unique pointer will ensure a unique copy of an object. There will be a single copy of it. There won't be any other copies, only a single copy, managed by that one unique pointer. Second, it will ensure that this object that is being managed by the unique pointer will be deleted when a unique pointer gets destroyed. Okay, and when a unique pointer is destroyed, well, when its destructor is called. So most unique pointers will have automatic storage duration, so they will be destroyed upon exiting a scope. Okay, now let's get into code. Okay, let's do this. Let's implement a unique pointer. So, as I said, unique pointer manages this resource via a pointer to it. So let's implement it. Let's make it private. A variable of type tPointer will be called row pointer, and let's initialize it with a null pointer. Now, there will be probably an implicitly defined constructor. We don't need to define it. I think we'll just start from the main constructor, let's call it that way. That will take in a tPointer variable as a parameter. Like that. Straightforward. Now, as I said, unique pointer cannot be copied. It represents a unique ownership. Okay? So we need to delete both copy constructor and copy assignment operators. We do this like that. We are not defining a name of it. It's not necessary since we won't ever use it. Now, we've deleted those. How do we pass around a unique pointer? Well, we use move semantics. So we need to define move operator and move constructor. How do we do this? We need to pass in an R value to a unique pointer. It's called other, and mark it as a noExcept function. So we want to run an exception. And now it's a move. So other variable will be cannibalized, which means that after move, other will have a null pointer assigned to it. So we want to assign a row pointer of the current unique pointer with value of a row pointer of the other variable, and then assign null to that other row pointer. We can achieve this using stdexchange function. stdexchange function was added, I think, in C++17. Now we'll do the same for move assignment operator. But remember, if the object currently manages something else, we need to delete it, otherwise it will be a memory leak. And we are returning dereferenced this. It can also be a void function. Return value isn't part of function signature, so it doesn't really matter here. Up to you. Now, unique pointer actually has a couple other functions, but before that, remember, we need to define a destructor. That's the part of resource acquisition is initialization idiom. Just delete row pointer. Lovely. Actually, that should probably have an underscore, signify that it's a member variable. Now that's better. Now to other member functions. Let's go. First, most trivial member function that you probably see is a get. Get just returns underlying pointer. Isconst is sometimes it's also marked as noexp. We can do this. And it just returns a row pointer. Now there's also an other function that returns a t star or underlying pointer. It's called release, and what release does is, well, it releases the ownership. So basically, it will return the underlying pointer and assign the row pointer of this unique pointer to null. So this unique pointer will no longer manage this resource. So we can again use the exchange, something that we just do all the time here. It's such a useful function. Use it more. So we just return std exchange. Like that. Lovely. Next, there is function reset. Reset basically it does what it says. It resets. It takes in a new pointer as a parameter, so it will delete an old row pointer and then assign a row pointer with a new value. Basic. There's also one last function that we're gonna define is a function swap. It just swaps values of row pointers between two unique pointer objects. I don't know if I ever used this one. That's something that's defined. Let's do this. It's simple. We can just use swap function to here. That's awesome. There are last two things we need to define, and that's a star operator, so the dereference operator. So we can basically by dereferencing a unique pointer, we can basically dereference an underlying pointer. And then there's also an arrow operator. So we can use arrow operator on a unique pointer as if it was just a normal row pointer. So let's start with a star operator, dereference operator. Yes. And it just returns a row pointer, a dereference row pointer, so a reference to an object actually, right? That the row pointer points to. And then let's define an arrow operator. Oh, that's crazy here. And it just returns a row pointer actually. So we can actually do like get here. It's actually the same, I think. So whichever is cooler, I guess. Get is like reusing code, so maybe it's better here. I don't know. It doesn't really matter, I think. But I think for more like readability, I will just return underlying pointer here. And now this is a perfectly well-defined unique pointer class. I mean, yeah. So let's take a look at it one more time. We declare a row pointer variable here. We make a default, not a default, but like the most basic constructor. We delete copying. We ensure movability. We ensure that upon exiting scope, for example, or just any other deletion of unique pointer, underlying resource also deleted. And then we have some auxiliary functions. That's really awesome. Now, one last thing we need to implement is a make unique. Why do we need to implement this? Okay, let's look at this example I have written. Let's say that there is some variable a, some resource, it doesn't really matter. The point is that there is two unique pointers pointing to it. So this thing already violates our principle that there should be single copy. But what's worse is that when the program exits scope, both P1 and P2 are deleted. So there is a double deletion. We try to delete this row pointer 2 times, and that's not really great, because what will happen is double deletion, and this is undefined behavior. So basically a bug. Don't do this. That is why we use make unique. It ensures that we create value together with unique pointer, and thanks to that there is no problem with multiple copies. So this is a more complex function, so watch out. It's obviously a template function, but unlike unique pointer, there are two template parameters. First one is straightforward, it's just type name t, so it's a type for the underlying pointer. And the second one is a pack parameter, it's a template pack parameter args. And you will see how it works in a second. Now we are making a pack of R-value pack args. It's used for perfect forwarding, and perfect forwarding ensures value category of each parameter. So if we pass in like an L value, R value, L value, it will basically preserve those value categories. It's really, really important. Of type T, I guess. I don't know if it's necessary to write this here, I think yes. Forward like that for each argument in a pack. I know this takes some time to understand, just look at it, and as I said, this ensures that if we call it with R values and L values, those value categories are preserved. Now, that will be about it. That's how you implement a unique pointer and make unique function. I hope this video was informational. You learned something, and that I didn't make a mistake anywhere here, because if so, that will be really embarrassing. Thanks, goodbye.